Now let's go to logical operators on vectors. So we're going to go back to working with vectors, and we'll talk about logical operators with vectors. Okay. So let's start off with the basic stuff. Now, our rule still holds about to do this, either both vectors must be the same length, or one must be a scalar, which is a vector of length 1. Okay, so now let's get into our operators. Let's go over here, and remember we have available to us equal to, not equal to, greater than equal to, less than equal to, not, which is just a tilde. We have and, which is the ampersand. We have or, which is the straight up and down bar. We have all and any. So that's a lot to cover. But once you get the hang of it, it's not that bad. So we start here. Let's use equal to. So now let's see it in scalars. So let's say if I have variable a equal to 2, b is equal to 4, then I can do things like these scalars. I can go, if I say c equal to, and I like to use parentheses around my statements because all these equal to's can get confusing. So this is the Boolean or logical statement. Does A equal to B? Okay, so the question would be, what is the value of C? Well, the value of C is A equal to B? No, it's not. So the value of C is false. But when you do this in MATLAB, it will actually come up as a 0. And then you'll have to look in the workspace to see that that is actually a logical, of type logical. C would actually be a variable of type logical, or class logical. So that's 2 scalars. Now let's define D equal to the vector, let's go 2, 4, 6, and E equal to the vector 1, 4, 5. Okay, so we can do a couple of things here. We can do the Boolean of these 2 vectors. So I say F equals D equal to E. Now what that's going to do is that's going to do an element by element Boolean expression of equal to between each one. So effectively that's going to say, is 2 equal to 1? Well, that's false. Is 4 equal to 4? Well, that's true. Is 6 equal to 5? Well, that's false. So F is going to be the Boolean vector, the vector of type class logical, false, true, false. Okay. So that's vector to vector. This is scalar to scalar. You can also do vector to scalar. So I could come in here and say G is equal to, does D equal A? And that's going to give, so now I say, is D that equal to the value of A? Is 2 equal to 2? Yes, that's true. Is 4 equal to 2? That's false. Is 6 equal to 2? That's false. So the resulting vector G would be true, false, false. Okay? So this part here, oops, that's really bad. This here is scalar to scalar. This one here is vector to vector. And this one here is vector to scalar. Okay, and you can get any of these combinations, and you just can replace this. I have the equal to comparison. I could have put any one of these comparisons in there as well. Okay, or at least any one of the ones above the line. These 4 down here are more combination. They allow us to combine different things. So we'll see that in a second. But so scalar to scalar, vector to vector, vector to scalar. Okay. So now, with that sort of understood, let me erase this. Let's give some examples. So let's go back. And once again, say A equals 2, B equals 4, C equals 2, 4, 6, D equals 1, 4, 5. Now, we can do a whole host of things. So let's look at some things. Let's say if I now say E equals C not equal to D. Okay. Once again, they have to be the same length. This is a vector-to-vector operation, and that's going to do an element by element. Is 2 not equal to 1? Well, that's true. Is 4 not equal to 4? Well, that's false. Is 6 not equal to 5? Well, that's true. Okay. We could do F C greater than or equal to B. So this is a vector to scalar, and so is 2 greater than or equal to 4? Well, that's false. Is 4 greater than or equal to 4? Yes, it's equal to, so that's true. Oops. That's true. Is 6 greater than or equal to 4? Well, that's true. Okay. Now, so in MATLAB, when you get the answer, it's not going to come back as true, false, true, or false, true, false. It's actually going to look like 1, 0, 1, and this one would be 0, 1, 1. Okay? And you're going to have to check the type because this looks like a vector with zeros and ones in it. You'll have to check the class or the type in the workspace that it will indicate that this is a vector of logical. Okay? So you can do all kinds of things with this. You can do all kinds of things with this, but let's now look at the ones below the line here. Oops, I wanted to keep that. Let's keep this piece here. Okay. In fact, actually I drew that line sort of in the wrong place. This not operator does some interesting things. All right. So now let's talk about this not operator. If I did, let's say, E equals A greater than B. Well, E is is 2 greater than 4? No, so that's false, right? But if I did f equals not, which is negation of a greater than b, then this part is false, but the not is going to turn the false to a true, so f is actually going to be true. So whenever you see this not, it's almost like the negative in math. Whenever you see this not in front of something, if it was true, it turns it false. If it was false, it turns it true. So that's the tilde or the not operator at work there. Okay. Now let's look at the and statement. These two, the and the or, allow you to combine logical statements. So let's say here E equals A greater than 1 and B less than 4. Okay, so you have to take it one step at a time. So let's look at this. A greater than 1 is 2 greater than 1. Yes, it is. So this part is true. So that's true. And is B less than 4? Well, B is 4, so it's 4 less than 4. No, it's not. That's false, right? So true and false, if you remember our truth table, and I'll do it very quickly over here. A and B. If you have false, false is false, false, true is false, true, false is false, and true, true is true. So this is true and false. So true and false is false. So your result here of this combination, this and statement, would be false. So likewise, if I did f equals A equal to and B equal to, then that's going to go true and true. Whoops, no, let me go 4 here. I want it to be true. So does A equal 2? Yes, it does. That's true. Does B equal 4? Yes, it does. That's true. And so the result is true, according to our truth table there. Okay? Let's look at the or statement. Same basic concept. If I have E equals A greater than 1 or B, let's say less than or greater than 4, then A greater than 1 is 2 greater than 1. Yes, it is. That's true. Or is B greater than 4? B greater than 4 is false. So true or false. Once again, we go to the truth table. Or B. False or false is false. Oops. False or true is true. True or false is true. True or true is true. Okay, so now I have a true or false. Reading from my truth table is true. Okay? And you can go on and combine it in a lot of different ways, but that's the basics. Okay. Now if we go to all, what all does is it takes a vector and tells you if everything in there is true, then the result is true. If anything in there is false, then the result is false. So if I did E equals all and I had a vector true, 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 then E is going to be true because all the things in there are true. If I had a vector F and I did all false, true, false, then all of these things are not true, so F is going to be false. Okay. Likewise, if I come through and do any sort of works the other way. So if I had E equals any true, false, true, I'll make this one false. So what any says is if anything in that vector is true, then the answer is true. And the only way to make any false is everything in the vector has to be false. Okay? Alright, so we're going to now go to the MATLAB version to take a look at sort of these functions and how they play out inside of MATLAB. We're going to use logical operators on vectors. So let's do what we did on the board. A equals 2, A equals 4, C equals the vector 2, 4, 6, D equals the vector 1, 4, 5. Okay, and then now we can do some logical stuff. I can say E equals, let's do some scalar operations. E equals A greater than B. So that's just asking, is A greater than B? I like to space my stuff out, but you know, the spaces really don't matter between the operators and the operands. So if I run this, and I've already saved this file, so it's not going to ask me to save it. If I do this, if you look down the command window, E equals 0, indicating that A is not greater than B. And over here, if you look in the workspace, you get E equals 0, and it's a logical 0 there. So I want to look a lot in the workspace because the workspace gives us the class or the type of the variables that we're dealing with. Okay, so you could ask, and you don't need these parentheses right now, but I like to use them just for consistency and to make things clear what's being, what operations are being performed. So you could do is A greater than 1. And over here, yes it is, so F is 1, which is a logical truth. You could ask is A not equal to B? And G equals true because A is not equal to B, so that's true. So you can go on and on with these logical operators and do a lot of comparisons. Let's look at some vector-to-vector stuff. Put some comments in here. This was scalar. Vector. H equals. So if we compare, let's do a C equal to B. So what you get here, the workspace is a 1x3 logical, which makes sense. There were 3 elements in C and D, and they have to be the same size. Remember that, or one has to be a scalar. And so we're going to have a 1 by 3 answer. The answer is actually down here in the command window where you see h equals 0, 1, 0. Well, let's look at that. 2, does 2 equal 1? No, so that gives you a 0. Does 4 equal 4? No, that gives you, yes it does, excuse me, so that gives you a 1. And does 6 equal 5? No, and so that gives you a 0. So that's why your h is equal to 0, 1, 0. Once you sort of get the hang of that, then sky's the limit here. Is do the C not equal to B? Okay. You do that, you see that your answer I is a 1 by 3 logical, and you go down here and you get I equals 1, 0, 1 because you're asking not equal to instead of equal to. So is 2 not equal to 1? Yes, that gives you a 1 in your output vector I. Is 4 not equal to 4? No. And so that gives you a 0. And is 6 not equal to 5? Yes, 6 is not equal to 5. So that's how that works. And you could do comparisons. So I could say is C greater than, and I could put another vector in there, 1, comma 1, comma 1, comma 1, comma 1. But let's not do that. I might be confusing with 2, comma 2, comma 2. And then I run that. And once again, J is 1 by 3 logical. And if you go down here, it's 0, 1, 1. So I'm asking, is C greater than 2, 2, 2? Well, the first element in C is not, so that gives us 0. And the next two are, so that's why we have 0, 1, 1 for J there. So that's vector to vector. You could go vector to scalar. C less than or equal to 4. So now it's going to compare each element in C, vector C, to the scalar value 4. And so when I run this, I get the answer 1, 1, 0. So C is 2 less than or equal to 4? Yes, so that's the first one. Is 4 less than or equal to 4? Yes, so that's the second one. And is 6 less than or equal to 4? No, and so that's the 0 on the end. And once again, K is a 1 by 3 logical. So this could go on and on and get a whole lot of different results. And this will be very useful as we move forward with MATLAB in the future. So those are sort of the operators, the scalar to scalar, vector to vector, and vector to scalar. Now let's look at the AND operator. Excuse me, let's look at the NOT operator. How about that? If we wanted to use the NOT operator, let's say, let me define a vector L that equals let's say L equals the vector true, false, true, false. Then I want to say M equals not L. Okay. Let's run this, and I'm going to leave the semicolon off both so we can see how they look in the command window. Put a semicolon on K here. Okay, so I run this, and if you look, L was true, false, false. M is the inverse of that, or the logical inverse of that, which is 0, 1, 0, 1. So that's what the NOT operator does. If we're doing the AND, which is the ampersand, for completeness sake, put here NOT is tilde. Then I can say N equals 1 less than 2, which is true, and 4 greater than 2. which is also true. So that's true and true, which will give me, when I run this, it gives me 1, and so the value for n is true. And this is all coming from the truth table. And the and truth table. So O equals, let's do false, and I know 16 greater than 9. I run that, and O is false. If you go over here to the workspace, you see that O is typed logical, and it's false because false and true, 16 greater than 9 is true. False and true gives a false according to the and truth table. Let's look at the OR. There's also that vertical line, or some people call it a pike. Let's see, P equals 1 greater than 2, or 4 less than 1. So that's false or false, and false or false according to the truth table, P is going to be false. Q equals true or false. So if I do that, then Q should equal 1, which it does because true or false is true. And so it's the same over here in the workspace. Okay. So that's not and or. The other is all. And so if I say R equals all, and then give it a vector true, true, true. All things in that vector are true, and so R will take on the value of 1, or true. If I do S equals all, and give it a vector false, true, true, 1 false makes the all equal to false, as you can see here with that 0 and that 0 there. And there's any, which is to say if anything is true, so I can go false, 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 true. If anything is true, then any will evaluate to true. And so there's a 1 there, a 1 there. And the only way to make any false is that all things have to be false. Okay, so there's U is now 0. Okay. That sort of is a brief overview of what you can do with logical operators in MATLAB with vectors. We will use these things over and over again during the class, and look at the different ways that they work out.